Welcome to Network Troubleshooting. As many of us know, networks do not always function as we would like. Therefore, one critical skill that all networkers should continuously work to develop is troubleshooting. A networker with good troubleshooting skills is always a tremendous asset to his or her employer. This presentation provides a framework for troubleshooting networks. Although each network outage has its own specific symptoms and causes, it is important to know and practice the methods presented in this video because they provide a systematic approach that will enable you to more quickly solve your network's problems. By now you should be very familiar with the characteristics and functions of the layers of both the OSI and TCP/IP models of networking. You also know that the many different types of network devices operate at specific OSI layers. Using your knowledge of the network layers, each of their functions, and the different layers at which network devices operate is a very powerful tool in the world of network troubleshooting. Using a layered model as a framework for networking enables us to use three different troubleshooting strategies. These are top-down, bottom-up, and divide and conquer. Based on the symptoms of your network problem, you may find it valuable to use one of these methods over the others. Let's take a look at each strategy. When using top-down troubleshooting, the networker begins troubleshooting at the application layer and works downward toward a solution. If you suspect that a problem is user-oriented or due to application software settings, the top-down troubleshooting approach should be used. Unfortunately, if the problem turns out to be in lower layers, time and effort is wasted when using this approach. As you might suspect, when using the bottom-up approach, the networker begins at the physical layer and works upward toward a solution. Using this approach can take a long time if the problem ends up being at the upper layers rather than the physical layer. Experienced troubleshooters prefer to use their past experience as guides and apply the divide and conquer strategy. This strategy is characterized by troubleshooting a specific layer of the OSI model and working up or down the model toward a solution. As you accumulate knowledge and gain experience as a troubleshooter, you will be able to use your knowledge and instincts to quickly diagnose problems and formulate solutions to a variety of network issues. Now that you know the different approaches that are valuable for troubleshooting, let's start building your knowledge base by introducing you to some common problems that occur at specific OSI layers. As you troubleshoot your network problems, think about the following common issues as potential causes. Lack of connectivity or slower than average connectivity can be caused by many physical layer issues. When troubleshooting at the physical layer, always consider seeking out faulty or incorrectly terminated cables, electrical interference, duplex settings, or even faulty ports as possible points of failure. Remember, the physical layer is responsible for the physical and electrical specifications for the transmission of bits from one host to another over the physical medium, either wired or wireless. So always be thinking about what may negatively impact these specifications when troubleshooting at the physical layer. Common Layer 2 issues include faulty NIC drivers or a faulty NIC, mismatched WAN encapsulation protocols, and excessive broadcasts due to large broadcast domains. The most common indicator of a Layer 2 problem is the line protocol down console message given after issuing the show interfaces command. Errors in IP addressing are some of the most common errors that occur at Layer 3. Errors in subnetting, route aggregation, and routing protocol implementation and interface addressing can quickly lead to entire network outages. Therefore, always review new addressing information before implementation. If addresses are being distributed by a DHCP server, make sure the DHCP server is correctly configured. Network address translation can also add a level of complexity to troubleshooting Layer 3 problems. Access lists and address pool information associated with NAT should be checked for accuracy. Layer 4 specifies the port numbers used to reach applications. Those port numbers in turn can be used by firewalls to filter application-specific traffic. Therefore, always consider a firewall configuration error if specific traffic types are not reaching the network or endpoints on the network. A common indication of Layer 4 problems is users reporting that some web services, especially video or audio, are not reachable. One way to isolate application layer errors from other lower layer problems is to first confirm that the network layer is functional. For example, if a workstation cannot access a web server, try pinging the IP address of the web server from the affected workstation. If the ping is successful, then layers 3 and below are functional. Firewalls can then be checked for proper Layer 4 rules. If web services still cannot be established, an upper layer issue probably exists. DNS settings, client and server application settings, or simply a mistyped URL can be the problem. Network troubleshooting is a skill that is continuously developed over many years. As a beginner, you should always start simple and use a systematic approach while using the OSI model as a framework. As you build your own knowledge base of network problems, their symptoms, and their solutions, troubleshooting, although challenging, will become a very rewarding part of your role as a network engineer.